Hi, welcome to another Level 2 Statistical Inference video. This is our third video on sampling. Now remember, if we choose a good sample, it'll represent our population well. That'll lead to an inference being reliable and trustworthy. But if our sample's not that well, doesn't represent the population well, then our inference is likely to be unreliable and untrustworthy. Right, we've already talked about simple random sampling in the last video, so now we're moving on to stratified sampling. We still need a sampling frame, and we still can say that every item in the population has the same chance of being selected. Finally, remember the key thing we want is at least 50 in each group. It's a bit more than our minimum sample size of 30, and that allows us to explore trends, patterns, distributions better, and be a little bit more representative. All right, let's get into stratified sampling. Now, if the two groups do not have a similar proportion of number of items in the population, then it may be better to use stratified sampling as our tool to select a sample. Stratified sampling ensures we have a similar proportion of items in our sample compared to the population, which means the sample is more likely to be a better representative of the population. For example, 37% year 11s in a population, we want our sample to have about 37% year 11s. Right, so here's the example. Example 2, stratified sampling. A team of scientists have been catching, tagging, releasing sharks within 50 kilometres of New Zealand shores between the years of 2007 and 2016. They have caught 2,527 sharks in this time. 1,155 females, 1,355 males. 17 of them are either unknown or undetermined sex. This creates a population that we're going to use to study. Now we need to create a sample from this population in the same proportion as the ratio of male to female. So we're not going 50%, 50%. We're going to do it in the same proportion as the male to female. Now when I do work out my percentages, it's pretty close to 50%. And to be honest, you could easily get away with simple random sampling. But we're going to be a bit trickier and not do 50%, 50%. We're going to do our proportions based on 46% female, 54% male. And here's how we're going to do it. Right, take our number of males divided by females to get 1.17. That is like a scale factor. Basically, we have one female for every 1.17 male, or 1.17 males for every one female in the group. So if we go to females and say, let's pick a sample of 50 for the females, we're not going to pick a sample size of 50 for the males. We're actually going to pick a sample size of 50 multiplied by the scale factor of 1.17 to get 58.5, which we're going to round to 59 sharks. So what that tells us is we're going to have 50 sharks in the female sample size and 59 in the male. Now I know we've got slightly different numbers. We're allowed different numbers, by the way. That's not a biggie. But it is now the same proportion as our sample of 46% females and 54% males. So if I pop out of here and just quickly go back and do our NZ grapher, right? Remember here is our 2,527 sharks. We're going to now click on sample and more, pick our sample, and we're going to sample based on their gender or their sex. Here is the amount of females and males and the 17 sharks that were cleaned out. Now remember, we're going to type in 50 females, but we're going to type in 59 males because we've determined that is the right proportion. So let's now go sample, and you can see now we've got a total of 109 sharks, 50 of them are females, and 59 of them are males. That's the right proportion based on the percentages we worked out earlier. So, popping back in here, we're going to wrap up the video, and thanks so much for watching.